This is 7.2, day 2. We've got 3 topics or 3 different types of equations or problems to do today. The first problem is going to tie together writing the equations this time. Just like last time when we dealt with parabolas, we were given a vertex and a p-value. We were able to then write the equation. Or if I gave you the focus and the vertex of a parabola, could you write the equation? And at that point, P was the key to all of it. Today, we need to not only just find a P value, because that's not going to help us with ellipses. We need to find an H and K value, where the center is, and then we got to find an A squared and a B squared value. Along that way, they very well could give you different information that goes along with it. They could instead give us a C value. They could give us a B or an A value. They may not give us the A, B, or C values directly. They instead are going to give you the foci points, the vertices or the co-vertices. They could give you the length of a major or minor axis. You got to know that there's a huge connection between where your focus or your foci are and your vertices. They follow each other. Wherever the vertices are, you'll find the foci in the same place, vice versa. Your co-vertices will be the other axes from your vertices. If you're given a length, that means you know a C value, an A value, or B value. You can square those and get those squared values for our problem. Also, if you're given 2 foci, 2 vertices, or 2 co-vertices, you can find the middle, and that will be your center, your H and K. So there's many different pieces of information that you're able to put together to write the equation. Now, I would think that since we're in the ellipse equations, most of us would understand that I'd have to do something on the lines of an equation that looks really like this with some form of A squared and B squared in one of those 2 boxes. They could switch them. I could be A squared, then B squared, or B squared, then A squared. It also depends on how much of your, or where your foci or your vertices lie. You guys get that, right? In our problem, I'm giving you the foci and I'm giving you the length of the major axis. If I give you the length of the major axis is 30, what is the major axis letter going to be? The major axis is your longer axis. Which one is it? It's A. What is A? If the whole thing is 30, what's A? It's not the square root of 30.
No, it's squaring. No.
Well, think about this. This means whether the major axis goes side to side or up and down, its total length is 30. Is A the whole distance all the way across? No, A is actually in the middle to the end. So it's not 30 for A, it's 15. So A is equal to 15. A squared is equal to
30.
No. Squared. 225. So we know A squared. That's awesome. So if I can find B squared, H and K, I'm done. So now I have to use some of my other information. Another piece of information is my foci. My foci say that they're going from 19.3 to negative 7.3. So guess what? Draw it out. Sketch it. Could I just draw a sketch and call this a focus? And this is my other focus. One's at 19.3. The other one's at negative 7.3. The center would be right down the middle someplace, right? And we know that if my focuses or foci run sideways, what other letter has to run sideways? Or what other points? The vertices. And if this is an ellipse, the foci are always In or out? In. So I have a vertice out here and a vertice out here. I think you guys should be able to agree with this, right? Yes. Which means that this distance all the way across is 30. So that means this distance was A, which was 15. That's how we got A squared. What would this distance here be? From C to F. The center to F. Which one is that? What follows A? B. No. C. C follows A. Remember, A gets us to a vertice. C gets us to the foci, or focus, and the focus is always in the same major axis as the vertices. So this is a C value. The problem is I don't know what C is directly. But C, as in center C, is where, according to the focus, or the foci. It's in between, in the middle. Now wait a minute. This point right here is 19.3. This point way over here is -7.3. What's this point? We know it's going to be what? Well, that one, it's true. It is that. It is 6 something. But I don't think that's the one that everybody would naturally say, I know the value of. If all of these are on the same line, what would have to be true about that point in the middle? 3. They have to have the same y value. 3. Now, how did you get 6? Because 6 is correct.
Oh, I just went like up 7, and then from 19 I did -7, and then it was 12, and then I just...
Right. Guys, take the average. Add the two numbers and divide by 2. -7 plus 19 is 12, and 12 divided by 2 is 6. Guess what? That center is really what letters? H and K. So that means I have H, I have K. Oh, wait. The major axis, guys, is going left and right. It's going in which direction? Horizontal, which are the X's. Your numbers, letters, follow what they are under. So if the A's are in the X direction, that means A squared should be under the X's, and therefore B squared's over here. So we know 225 has to be under the X squared part. I have A squared, I have H, I have K. I now need to find B. B is your minor axis. It has nothing, I don't have any information about my minor axis. What's the link between my A's, my B's, and my C's? C squared is equal to A squared minus B squared. I know A squared. Do I know C squared? Do I know B squared? Here's the thing. I actually can find one of those right now. Which one can I find? C, or C squared. C is the distance from the center to the focus. Which means, what was this distance? 13. From 6 to 19 is 13. So C squared is equal to 169. And wait a minute. If I take my calculations for C squared equals A squared minus B squared, and I got to solve for B squared. Couldn't I switch B squared and C squared around? Bring one to one side, bring one to the other. So B squared equals A squared minus C squared. Or b squared equals 225 minus 169? Or b squared equals 56? Do I need to know what b is? Do I care? No, because I have to use b squared in my equation, not b. Now, if I was going to graph it, then I would want to have b squared. But I don't. I'm not graphing it. I just want the equation. So this becomes x minus something squared plus y minus something squared over equals 1. What is x minus what? 6. Y minus 3. It's x squared minus 6 over 225. And the other number? 56 is equal to 1. You now just written the equation. The next one is eccentricity of an ellipse. Basically, how much of an ellipse is it? Is it circulish or is it ellipsish? Okay. Now, this E value has a ratio of C divided by A. It goes between 0, absolutely no ellipsoidishness to it, to 1, meaning, hey, this thing really looks like an ellipse. So, is it just more circular than it is more of an oval shape? So, if you can tell, or you can see there, that we have our same formula set equal to 1, same equation, c squared equals a squared minus b squared. There's your connections. The eccentricity is E equals c over a. It's just a ratio of the distance to the foci divided by the distance to the vertices. Sorry, numbers you have. I'm not having you guys do this to necessarily do anything groundbreaking here. I just want you guys to have another tool that if I gave you a set of ellipses and I said, here's the equations, could you kind of give me an idea of which ones should match which equations? And you can do this by determining the E value for all of the graphs and say, hey, this one says it should be more of a circle, and this one says it should be more like an ellipse. Therefore, you have another way to help identify if you're doing something right or wrong. I like to think of this as on a scale. This scale says, hey, I got things that look like ellipses. I got things that kind of look like they're ellipses. And then I got things that I say don't look like an ellipse at all. This has a value of 1 on the scale versus the circle has a value of 0. And so it goes somewhere in between 0 and 1, or 1 and 0. The closer you are to 1, the more stretched out of an ellipse it looks like. Otherwise, if it has a value of 0, there won't be much in the lines of any stretch. Okay? So, given the equation there, determine the eccentricity of that ellipse. On your own, find A, find C, and tell me the value. So, to make this happen, all I need to know is A squared and C squared, and take the square roots. But to do that, I need A squared, B squared to find C squared. A squared is equal to what, guys? It's 19. It's the larger number. Which means A has to equal the square root of 19. B squared is what? 17. Do I actually care what B is? No. But I need to know C squared. So C squared is A squared minus B squared, which is 19 minus 17, which is 2, which means C is equal to the square root of 2. which means eccentricity ratio is the square root of 2 over the square root of 19, which happens to be point what? 324. So, up there on my little scale, is this going to be more circlish or ellipsish? It's probably more circlish. Somewhere in the middle, though. So it looks like a circle, but with maybe a slight wobble to it. Yes? So someone's got a slight squish going on here. But here's the thing, is if I gave you two equations and asked you which one is more of an ellipse shape, you can compare their numbers. The one with the larger e value would be the graph or the equation, or the equation that has to be more of an ellipsoid. And the last topic is circles. Now we also talked about, guys, that all circles are technically ellipses. But not all ellipses are circles. I can write an equation of a circle as an ellipse. The only modification is the fact that a squared and b squared happen to be the same value. And wait a minute. If a squared and b squared are the same value, that means I can go left right from the center as the same as I go up and down. That means it's a perfect square box, which means a nice circle can be drawn inside. Yes? Also, on the E scale, if a squared and b squared are the same, then c squared would equal 0. And 0 divided by a squared is still 0, and therefore it would be a 0 on the scale, which means it is a circle. Now, that's our equation. X minus h squared plus y minus k squared equals r squared. If I wanted to make this into an ellipse, I would just divide both sides by r squared to make that r squared value equal 1. But I just have r squared. It would be over r squared, which is a and b, which is the same number, which then creates you going the same distance away from the center. We talked about that. So therefore, because they were the same, we multiplied it over, we called it the radius. So we also talked about the fact that all of our conic sections can come into this general form. We talked about if there was only one term with a square, then you know it's a parabola. You only have to complete the square once. From here on out, you're going to have an x squared and a y squared. I can tell you this is a circle. It's a circle because the coefficient on x squared and y squared is the same. Because these are the same, they are a circle. And if it's a circle, we can graph it differently than an ellipse. But say I didn't recognize that. To put this into standard form, even for an ellipse, I need to complete the square not once, but twice. So let's do that. To do this, everybody should already know that you really should group up your x's, group up your y's. Notice I did not add anything to both sides because your a value is not 1 in any of the cases, are they? But I saw someone try to do this in their homework last night, and it gave them some really crazy numbers. They wanted to divide both sides by a number that not every number was divisible by. Don't do that. It's going to cause you more of a headache than anything else. In this case, They all are divisible by 4. You could do that. What if I said, I don't recognize that, or I'm going to ignore the fact that I can divide both sides by 4? Let's do it the long way. The long way says, I need to take the x's and take a 4 out of those because the 4 can go into those. So 4x squared minus 6x plus something plus, hey, I can take a 4 out of these guys too, yeah? Plus 8y plus something equals negative 36 plus something plus something. I'm going to add something to both sides. Got to balance it out. What do I add in the first group with x's?
9.
It's a 9, but it's really just negative 3 squared because half of negative 6 is negative 3. Negative 3 squared is 9. What do I add to the other side, though? 36. Because it's 9 times 4, which is 36. Over here, what's half of 8?
4.
So it ends up being 4 squared. And 4 squared times 4, so 16 times 4? 64. Hopefully everybody recognizes the 36s actually cancel each other out. Which leaves me with x minus 3 squared plus 4 times y plus 4 squared equals 64. Now, we have options. If I was creating an ellipse, I would divide both sides by 64 and reduce the fractions. If I did that, I would have x minus 3 squared plus y plus 4 squared over equals 1, 16 on both of those. Notice your a squared and b squared are the same. Tells you it's a circle. If I recognize that the coefficient on a squared, x squared and y squared are the same, I can just divide everything by 4. So I'll do that over here. So I get x minus 3 squared plus y plus 4 squared equals 16. Notice they are the same thing. I could go over here and multiply both sides by 16. I'll have a 16 then. Your center is at 3, negative 4. R squared is 16, so R is equal to 4. All I'm doing then is I'm graphing this at 1, 2, 3, 1, 2, 3, 4. And then I'm going to go 4 up here, 4 backwards here, 4 over, way over there, and down off the graph there, so a circle. I go 4 in every direction. I think graphing circles is probably one of the easiest things we'll do in this class. You plot a point and move left, right, up, and down the distance of R, circle it up. Done. Homework for 7.2, day 2, 438, 12 through 15, 24 through 26. On 12 and 13, you have to take the information, write the equation. On 14, 15, I want you to find the E value. Should go quick. And then 24, 25, and 26. It is one problem of each type. There's one parabola, there's one circle, and one ellipse. You need to take the general form, understand which equation you're looking for, and write it in its standard form, and then graph it. Have a great day.